Welcome to episode 2 of Geometry Nodes inside of Blender. Today we want to actually use geometry nodes to build the alien rock that you saw in the intro. To get started, let's import some geometry, but before we do that, select everything and get rid of it. Now, file import a wavefront file that you can download from the link in the video description. Blob is the object that you can download and import it. That is a geometry that I built for you. With this object selected, let's create a new panel and then switch this panel over to Geometry Node Editor and press the new button to create a new geometry node setup. You see that a new modifier is added called Geometry Nodes. Let's rename this node tree to Alien Rock. That is what we want to build. And it changes the name here because this is a link field referencing this node tree. Now, what do you have here? You have two nodes. A node is this box with the group input that encapsulates exactly one function. And a node has inputs and outputs. That is these little circles here. The outputs are on the right of the node and the inputs are on the left of the node. If you hover over one of these ports, you get some information about what is coming out of the port. So data comes out of output ports and goes into input ports. And between these two ports you have a wire. This wire is a connection, so you can think of it like a pipeline, and the data comes out of this port and it flows along this wire and enters the group output node. These two nodes are standard. Every empty node tree comes with these two nodes, and what they do is the group input reads the actual polygon data of the object that the node tree is attached to. So in our case, it reads the data from this green blob 01.002 data block. All the points and polygons that are in here come out of this geometry port. You see, we have 713 vertices, 2133 edges, and 1422 faces coming out of here. Now, the group output is the output of the modifier. In goes the geometry that is then passed on to Blender for display in the viewport and for rendering. If you click on a port and drag, you get one new connection, and you can connect this to any port that you find. If you already have a connection, you can click on the port where it goes in, and then you can just drag it to anywhere and cut it. You see, as soon as I cut this connection, all the geometry vanishes, because now the chain is broken. The data still comes out of this port, but it is not passed on to the output. So the entire polygonal description of the object gets overridden by nothing, and that is why we don't see anything. That means our coordinate system is still there, but we have no polygons and no points to display. If we connect this again, our object is back. Now, we can decide to create new nodes to alter this geometry, or we can even create entirely new geometry. How do we get new nodes? There are different possibilities. Either you go to this Add menu, and here you have a lot of categories, and in each category you find a lot of nodes doing different things, or you can press Shift-A, and then you get this menu with the same categories, but with a search field added. If you later on know the names of your nodes, you can just go to search and then write, for example, cube, and it will filter all the nodes to find the cube. If you then click on cube, you get a new cube node. This cube node is a generator. So this node has inputs, the parameters, and the output geometry. You can differentiate between the different types of data that are going into nodes and coming out of nodes by the color of the ports. And this green color here means geometry. So you see, out of this node comes the geometry. And this node just creates a cube. So if you take the geometry that comes out of this node and connect it to the output of our modifier, you see that we create a cube, because now this node creates a cube and passes the data on to this output. And then the modifier passes it on to Blender, and Blender displays it. So either we use the data from the object itself, or we create entirely new data. What we want to do is to alter the data that we have here. So if you have a look, let me quickly turn on wireframe. This object is composed of triangles. What we want to do now is to create the dual graph. So I want to take this polygonal description, and then I want to find the midpoints of each polygon, and then connect these with edges to create a new polygon. And I want to do this for all the polygons. This will change the topology dramatically. Fortunately, we have a node for this, and it is called dual mesh. So let's create a dual mesh node. It has two inputs and one output. In goes the mesh, that is the data to modify, and out comes the modified data. And then we can set if we want to keep the boundaries. So let's wire our geometry into this mesh port and then the output to the geometry port. And you see roughly what I've drawn. It turns all the triangles into n-gons. And these n-gons look quite interesting because they look a little bit like honeycombs or something. Let me get rid of the annotations quickly. So now we defined an algorithm. We are reading the polygon data from the object, then we are changing the polygon data and fill the temporary cache for replacing the original polygon data. But it does not stop here. The next step is that we want to extrude inner. I want to create little polygons inside of all these polygons. With geometry nodes, that is a two-step process. First, we extrude and then we scale the extruded faces. So let's see if we find a node that extrudes faces. Shift A again, search and then extrude. And here we have the extrude mesh node. So let's wire the output of this dual mesh into this extrude node and then the output of the extrude node into the geometry output. And you see it does what it is intended to do. It extrudes each and every face. You have a checkbox for individual down there. If you tick this off, it extrudes everything as one surface. But we want to extrude the individual faces. The offset scale can be used to tell the node how far it should extrude. We don't want to extrude at all. We just want to create the new polygon, so we set this to 0. If you now hover over the port here, you see that we have 713 faces, and if you hover over the port here, you see that we have 4,979 faces. Because this node constructs new faces for each face that it finds. Now that we have all these faces, we can scale them. And for this we have another node called scale elements. So look for the node called scale elements and then introduce it here. Instead of connecting this output to this input and then this output to this input manually, you can just take this node and drop it on the connection between these two nodes and it will happily integrate this node into the flow. Now we have a scale elements node. If we alter the scale parameter, each element is scaled. That is not what we want. We just want to scale the faces that are created by this extrude mesh node. And fortunately, we not only have a mesh port here, but we have more information coming out of this node. We have a top and a side output. The top output spits out all the faces on top of the extrusion. Let me extrude a little. So these faces here, the top and the side output tells you about the faces on the sides. So let's go back down to 0 here. And now let's connect this top output to the selection of this scale element. And if I do that, you can see that I now, by altering the scale parameter, can scale only the top faces, creating an inset. Now to create this alien rock, we want to poke holes into the geometry. So we have to get rid of these faces. Let's see if we find a node for deleting geometry. If I put delete into the search field, we see we get delete geometry. And delete geometry, just like the scale elements, has a selection port. So let's connect delete geometry here and everything vanishes because, of course, all the geometry is deleted. But if we now just take this selection that comes out of this top port and connect it to this selection here, then it only deletes the top faces. But why are we left with these edges only? Because the delete geometry node is set to point, so it deletes all the points of the faces, and thus the neighboring faces too. So let's switch this over to face, and that pokes holes into our surface. So now we actually have holes here. Great, now I want to have thickness, so why don't I just reuse this extrude mesh? And you can do that by selecting the node, pressing Shift D, and you get a second version of it, and let's put it here. And this time we actually want to use the offset scale, set it to 0.1. And we don't want to tick individual in this case because we want to create thickness. And now we have an object with thickness. The problem is that we don't have interior faces because the extrusion operation just extrudes the faces outwards. So we have to somehow create these interior faces. To do this, we have to learn a new concept of geometry nodes, and that is branching of geometry streams. So far, we just created a linear flow of operators. The geometry flows through all these nodes and gets altered with every node. But what we can do inside of geometry nodes is we can branch off. We can create a different stream of geometry and then even merge this back into the original stream. And that is what I want to do now. So remember, if I temporarily connect the output of delete geometry to my output here, you see that was a state where we had the faces. And now we extrude them. So basically, I want to keep these and merge them with the result of this extrude mesh, and I can do so. But the problem is that these faces have a normal that points outward, so to the outside of the object. But what I need is the same polygons with the normals flipped. So let's use a node to flip the normals of these faces, flipped faces here, and put it up here. And now wire this delete geometry output to this mesh. Let's temporarily connect it here to see what it gives, and it shows us that we have the same geometry but with flipped normals. We can check this by going to the overlay section and ticking on face orientation, and you see if I temporarily mute this node by pressing the M key over the node, you see now these faces are blue, and if I make the node work again, they are red, so they are flipped. So out of this port comes these faces with the flipped normals, and out of this port comes the geometry that is open on the inside. Now I want to combine both. because I want to create a solid object. And for this we have the join geometry node, join. This allows us to join geometry streams. So if I wire this in, and you see you have a different type of input port here, it is elongated, indicating that you can put multiple streams of geometry into this port. Now this node joins these two geometry streams together, and if I connect this to the output, you see now I have an object with an outside and an inside. The magic of geometry nodes is that by just branching off this geometry, I actually duplicate it. So I have now two geometries and I can join them back together, duplicating the interior faces. Now, this is nice. Let me get rid of the face orientation, but it's still quite polygonal. What if we do some subdivision? And even for subdivision surfaces, there is a node. So you could, in theory, of course, combine the geometry nodes modifier with a subdivision surface modifier. But why if we can do it inside of the tree with the node, subdivision surface? And it goes here at the very end and it creates a subdivision surface. Let's up the level to 2 and let's get rid of the wireframe. This looks promising, but we have a little problem here. If you look at the inside, you see the inside edges are hard, and that is due to the construction of the geometry. We duplicated the geometry and then we joined it together, meaning that at this border here we have double points. And because we have double points here, the individual faces are not connected, the subdivision surface will not smooth out this border. To change this, while modeling, we would use merge by distance. And we can do the same inside of the geometry nodes tree procedurally. So let's lay down a merge by distance node, and it has a distance threshold just like the command that you know from the editor. And before we do the subdivision surface, let's just add this merge by distance here. And you see, as soon as I do that, all the points get merged and we have one geometry now that smoothes nicely. So the very last thing is that this is faceted, and I could in theory go to shade smooth, but unfortunately this does not change anything. And that is because you have to set the smoothing behavior not by using the command, but by using another node. So the very last node that I want to use here is called set shade smooth, and it allows you to set the smooth criterion on the geometry, as you can see here. And now we created our alien rock. And the good thing about this is that this is all completely procedural. So that means if I just create a new object, say a sphere, icosphere, and let's move this over a little bit. Now I can go here, create a new geometry nodes node tree, and then switch this out for the alien rock that we created. And you see, this operator is now using the same algorithm, creating the same effect with a different geometry. So what you did here is not just modeling one alien rock, but instead you created a tool that you can reuse as often as you want by just creating a chain of commands that tells Blender what to do with the incoming data. Very handy if you ask me. So this is working with geometry inside of geometry nodes. Just create different nodes, procedurally altering the polygonal data that comes in and passing it on to the output.